Teacher knowledge and behavior is the component of the model that focuses on teachers' knowledge of students and content and on their expertise in classroom management and pedagogy. Teacher knowledge is the element of teacher knowledge and behavior that encompasses knowledge of student characteristics and teachers' in-depth content knowledge, and the blending of these to enhance learning. More information on this can be found in the Technology as Facilitator of Quality Education model. The teacher's in-depth knowledge is evident in his use of discovery learning as a method of instruction. The teacher reviews the student's prior knowledge of force, mass, velocity, and acceleration, and he provides them with general guidelines and useful materials for the activity.
Variable X, variable Y. If I get a line shaped in that general direction, what does that mean? Jeff?
It's like directly, one is directly proportional to the other.
Directly proportional. What happens if we see a shape that doesn't look like that, does something like that? Lori?
Oh God, I really don't know.
It's okay. James?
Well, it's not directly proportional.
It's not it's indirectly proportional. Lori, you did know after all. If you push or pull something, what happens to it?
Moves.
It moves. And if it moves, it's changing its velocity, so there it's accelerating. So we know that we're going to have these two. Well, whatever we're moving has what?
Mass.
Mass. So by default, we've got three variables that we've got to deal with.
But he lets the students design their own experiments, record their own data, and come to their own conclusions about the relationship between force, mass, and acceleration.
Go back, wander around, peek at what I've got there. If you know what I've got there, if you've already looked, that's fine. Peek, get in your groups, move your desks together, make a plan as a group. Who's going to do what? What are you going to do? And let's show it to me and let's go back.
The teacher shows his knowledge of student characteristics by giving the students the opportunity to design and carry out hands-on experiments. As the students conduct their experiments, they use their bodily kinesthetic intelligence to manipulate the cars, tracks, pulleys, and photo gates they use to gather data.
Okay, ready? Uh-oh, what if it lands on my toe? Ready?
You need to have a relationship between mass and acceleration. The mass goes up, what happens to the acceleration?
Acceleration increases. Okay, I can do that.
The teacher also addresses the learner's logical mathematical intelligence. Once the students have gathered their data on force, mass, and acceleration, they have to determine the mathematical relationships between them by plotting graphs. The teacher's in-depth content knowledge is evident in his explanation of the objectives for this activity.
The goals probably look in our curriculum guides. They'll be the relationship between mass and acceleration. That is, if you use a Bloom's type goal, it would be the relationship between mass and acceleration, between force and mass, and Newton's second law. They're all interrelated. Other things that we do, we try to work in groups. We're trying to learn to cooperate, trying to learn to get along with each other and divide up part of the workload. You'll see the kids, do a pretty good job of, this is my job, this is my job, this is my job. The kids stayed pretty much in their role, and those roles do change as time goes on. They knew what their roles are right now, and then if, like Amy, when you were watching the activity, was catching the car, well, the next time we do this, she'll probably be running the computer. So we do divide up our roles, and that is a goal that's hard to measure, but it's one of our goals is to learn how to work as a group and be cooperative.
Teacher comprehension of purpose is a vital part of content knowledge. The teacher states clear goals for learning physics concepts and for learning to work cooperatively. The teacher also engages in reflection. In analyzing his teaching practice, the teacher notes the reason this lesson is successful. Giving students a practical application of graphing helps them understand not only the concepts of force, mass, and acceleration, but also the process of graphing itself.
When kids start to understand graphing, every kid knows how to graph when they're in 8th grade. They understand the y-axis and the x-axis, and they start putting points out and they make a line. But when they start seeing the relationships, hey, this y-axis is actually force and this x-axis is actually acceleration, and they start seeing that if one changes, the line starts to move, and that is when they really start to understand what physics is all about. And then we start talking about the slope of the line and the area underneath the graph, and then they really understand graphing. All kids know how to graph, but not all kids understand what graphs mean until they see a practical application of physics.